So this is question 12 on the P3 section of the OCR specimen paper for Gateway Science. Pat measures the speeds of two cars. The diagram shows the speeds of the two cars. Here's car A, speed's 9 meters per second, car B is 15 meters per second. And the question just asks you to calculate the relative velocity of car A and car B. So what does that mean? Relative. Well, relative velocity is what it would seem like if we were in a different position. So what would the velocity of car B seem like if you were on the position of car A? Have a little go at that, pause it now, and then I'll show you the answer. Okay, well hopefully you realised that if you were sat in car A, then car B would be getting further away from you. It would seem like it was speeding off from you. But because you're travelling 9 meters per second, the relative velocity would be the difference between the two. So car B is travelling 15, car A is travelling 9, so the relative velocity is 6 meters per second. It seems like it's increasing, it seems like it's moving away from you. Well, it is, but it's not moving as fast away from you as if you were stationary. I hope that little bit makes sense there. It does need to be 6. In this case, you do not need the units for the mark, but that's not usual, so make sure you do put units on your answers. Okay, moving on to the next one. Car A accelerates and after 4 seconds is travelling at the same speed as car B. Calculate the acceleration of car A. So you've got the extra data now, 4 seconds, and from the last question we've already got the difference in velocity as 6 meters per second. So you can now calculate the acceleration. I'll give you a clue. Go ahead and find the equation from the equation bank at the front of the paper and have a go at this. Although this should be a pretty snappy skill, pretty quick skill, because it's only worth 1 mark. And this time you can see there is a box for the units. The units are important for this mark. Okay, pause the video and have a go. Okay, well, welcome back, and hopefully you've seen the equation is acceleration equals change in speed divided by time. So it's sped up to the same speed as the other car, the faster car. So the change in speed is the difference, is 6. And the time it took is given in the question, it's 4 seconds. 6 divided by 4, doing a calculator, it's pretty simple, it's 1.5. And the unit of acceleration is meters per second squared. And that is a very often missed out thing, that meters per second squared, and you need both of these parts exactly like that for the 1 mark that's available. Okay, moving on to the next part. This is about stopping distances. Now it's quite a complicated little question actually this, and I've got a video all about forces and stopping. So if you fancy that, before having a go at this, maybe go check that video out. The driver of car B presses the brakes, the car stops. Now look at the information about the car stopping. There's quite a bit of information. The thinking distance is 10 meters and the braking distance is 25. So this thinking distance is the distance the car travels whilst he's making the decision to press the brake. It's like saying it's the distance the car travels during his reaction time, if you like. And the braking distance is actually the distance the car travels whilst the brakes are doing the mechanical work of actually slowing down and stopping the car. So, explain what happens to the thinking distance and the braking distance when the speed of the car triples. Okay, it's 2 marks, so 1 for how the thinking distance changes as the speed triples, and 1 for the braking distance when the speed triples. Okay, quite a tough one, but everyone I think can at least get the first mark, I hope. And maybe this is just a bit of remembering how the braking distance changes compared to the thinking distance. Pause the video now. Well, because the thinking distance increases linearly with speed, then if the speed triples, then thinking distance also triples. Okay, simply put, the reaction time is always going to be the same. If the speed's 3 times as fast, then the distance is 3 times as far. That's pretty simple, really. The thinking distance triples. But the braking distance is slightly different because it's dissipating kinetic energy into the form of heat. It's actually a square relationship. If you can imagine in maths, it's a y equals x squared relationship. Think about the shape of that. So actually, it will be 9 times as fast. Sorry, 9 times as far. The braking distance will increase by 3 squared, which is 9 times. Very, very interesting point to make. You could do yourself a little sketch there. You could say that would be thinking distance if that was distance and that was speed, and this would be braking distance if that was speed and that was distance. Okay.